Quadratic inequalities. With inequalities of a higher degree, like degree of 2, degree of 3, or higher, it's helpful to view them in factored form to determine the zero values. Now, why is it important to determine zero values? Well, 0 is the number that separates the negatives from the positives. So if we know where the zeros lie, then we can determine where the negatives and positives lie. So let's take a look at how we're going to solve a quadratic inequality. Kind of like that second method I used where we changed our inequality into an equation, that's the route we're going to go. And so once we change it to an equation, we can find zero values by factoring and solving. And then we're going to test each region on the number line to determine which one is going to make our inequality true. So let's start with example 7. I'm going to change it to 3x squared minus 11x equals 4 and move that 4 over to the left. So we have 3x squared minus 11x minus 4 equals 0. This is one of those where we could go ahead and try to factor by trial and error, or we could use that other method where we're going to take 3 times negative 4 and it's got to multiply to equal negative 12, but our special numbers need to add to be negative 11. And I think we get that with a positive 1 and a negative 12. So those important numbers replace our negative 11 in the middle to 1x and a negative 12x, leaving the 3x squared and the minus 4, and then we factor 2 terms at a time. So here we would factor out the common x, leaving 3x plus 1. And if we have chosen our special numbers correctly, then we should also be able to factor out something here, in this case a negative 4, and inside the parentheses we're going to notice that it matches what we had before. So our common factor is now the 3x plus 1 that we're going to factor to the front, and then what it gets distributed to is the x minus 4. And that's our factored form. We can find the zeros by setting each one of these equal to 0. In the first case, we end up with 3x equals negative 1, or x equals negative 1/3. In the second case, we get x equals 4. So the important numbers, these are our zero values that are going to separate our positives from negatives. And so on our number line, on the left, I'll put negative 1/3, and on the right, I'll put 4. And we're going to test each region. You know that I always like to test x equals 0 if it's possible. And now I'm going to pick something left of negative 1/3, like negative 1. And I'm going to pick something right of 4, like 5. And again, you could pick 100, your choice. Any number over here on the right of 4 or on the left of negative 1/3 would work. So I'm going to go ahead and sub that into our original inequality. So I've got 3 times negative 1 squared minus 11 times negative 1, and is that greater than 4? So 3 times 1 would be 3, negative 11 times negative 1 would be positive 11, and is 14 bigger than 4? Our answer is yes, and so we'd shade in that section. In the middle at x equals 0, we have 3 times 0 squared minus 11 times 0. Is that bigger than 4? We basically end up with 0 on the left because we have 0 minus a 0. Is 0 greater than 4? We get a no. Using 5, 3 times 5 squared minus 11 times 5. Is that bigger than 4? So 3 times 25 minus 55. Is that bigger than 4? 75 minus 55 is 20. And yes, that is bigger than 4, so we'll shade in that section. I like to go back now and decide, do I want open circle parentheses or closed circles? Because it was a greater than, there's no equal to sign. That means we're going to use an open circle or a parenthesis on those ends. So our answer in interval notation would be negative infinity to negative 1/3 parenthesis, and then also 4 to infinity with a parenthesis. And I put the union in the middle to say our answer could appear in this section or in this section. Example 8. Solve 2x cubed minus 5x squared is greater than 0. In this case, it's already got it equal to 0. Let me go ahead and convert into an equal sign. And then I'm going to factor out the common x squared, and then I'll have 2x minus 5. And now we're already factored, so I'm going to set each factor equal to 0. and solve from there. So here we get x equals 0, and a positive and negative 0 are both the same 0. And solving the second equation, we get 5/2, which is 2.5. So now, because we used an equal sign, we need to check each interval, and we have 0 and we have 2.5 on our number line. So I can't test 0 this time because that's one of my 0 values, and I need to find the positives and negatives around it. So I'm going to check something like -1, +1 fits here, and then maybe I'll also try the number 3, or again, you could pick 10 or something larger. So checking with -1, I have 2 times -1 cubed minus 5 times -1 squared. Is that bigger than 0? So I get 2 times -1, -5 and -1 make +5. Excuse me. Let me go back a second. I didn't see that square initially. Minus 5 times -1 squared is 1. And so -2 minus 5, is that bigger than 0? -7 is not bigger than 0, so that's a no in that section. Let's go ahead and try it with +1. 2 times +1 cubed, -5 times +1 squared, is that greater than 0? 2 times 1 is 2, and 5 times 1 is 5, but remember we have that minus. And 2 minus 5 is -3. Is -3 greater than 0? Notice that we also got a no here. So it's not always the pattern that you go yes, no, yes, or no, yes, no. In this case, we had a no next to a no. Let's try x equals 3. 2 times 3 cubed minus 5 times 3 squared. Is that greater than 0? Again, we're going back to the original inequality. So 2 times 27, 5 times 9. 2 times 27 would be 54. 5 times 9 is 45. And 54 minus 45, we can do a little bit of arithmetic. We would end up with 9. Is 9 greater than 0? And our answer is yes. And so this is the part we're going to shade. Because it was originally just a greater than, we would use an open circle. And then our answer in interval notation would be 5/2, comma, infinity, with a parenthesis on the 5/2. Let's take a look at one more example, example 9. A word problem. A projectile is launched from ground level with the initial velocity of 144 feet per second. Its height is in feet, so kind of keep in mind the feet and the feet label match, so we don't have to convert from feet to inches or meters. T seconds after launching. And our equation for height is height equals -16 t squared plus 144 t. And our height is the variable s, it's in feet. Our t is the variable time, and that's in seconds. When will the projectile be greater than 128 feet above the ground? So I'm going to take that height equation, and I want to make it greater than 128 feet. So our height equation is -16 t squared plus 144 t, and that needs to be bigger than 128 feet. I'm going to solve like we have been. I'm going to use an equal sign, -16 t squared plus 144 t equals 128. And then on my number line, I'll separate it into regions and test each section. Moving my 128 over to the left, we have -16 t squared plus 144 t minus 128 equals 0. Now, I've actually looked ahead, and I can divide each one of these by -16. Whoops, excuse me. This should just say -128. So here we end up with 1 t squared. Here we're going to have a negative, and 144 divided by -16. You could take the time to simplify. I usually go ahead and just, if I can, cut it in half, divide by 2. So I get 72 over -8, and that very quickly told me it was -9 t. And then I would do the same thing with 128 over 16. They both end up being positive. Dividing both of them by 2, I get 64 over 8, which reduces down to an 8. And then from there we can factor. This one would factor to t minus 8 and t minus 1 equals 0. And we get t minus 8 equals 0, or our time is 8 seconds. T minus 1 equals 0, or our time is 1 second. Again, put those on a number line and check each region. Okay. Here x equals 0 is in the region. Here's something like x equals 2, 3, 4. And here I'm going to use x equals 10. So at x equals 0, I'm going to go back to my original here. So negative 16 times 0 squared plus 144 times 0, is that bigger than 128? And we get 0 bigger than 128. That's a no. In the middle, we have negative 16 times 2 squared plus 144 times 2. Is that bigger than 128? So I have negative 16 times 4, which ends up being negative 64. And then we end up with 144 times 2 is 288. Is that bigger than 128? And negative 64 plus 288 equals 224. So yes, that does work. So I can shade where we tested that region. Okay. Again, kind of looking back, because we were only looking at a greater than, no equal sign, these will be open circles. And then checking with a 10, I have negative 16 times 10 squared plus 144 times 10. Is that greater than 128? So negative 16 times 100 would be negative 1,600. Plus 144 times 10 would be 1,440. Is that bigger than 128? And adding these two together, we have more negatives than positives, so we should end up with a negative number. And that should be enough to tell us that the left side is not bigger than the right, but we could go ahead and finish that, and we end up again with a no. So our answer should be from 1 second to 8 seconds, means that our height will be greater than 128 feet. And that ends example 9.